Here we go, polar area, day 2. So we're going to find the area inside, r equals 3 sine theta, and outside of 2 minus sine theta. And on these, we need to draw pictures, okay? We need to figure out what's going on with these problems. So what is this r equals 3 sine theta? What is that? That's a circle. What do we know about that circle? The diameter is 3. And which way is it going? It is going up. All right. And so we have a circle going up. All right. And then it says it's outside r equals 2 minus sine theta. And so what is that? That's a flat butt. And where's the bulk of it? Down. All right. And so then the little flat cheeks are up. All right. And so what it says is it's finding the area outside or inside of this one and outside of that one. And so the area that we're finding is that portion right there. So before we even do this problem, we kind of need to figure out what it's looking like. And that's our little picture to figure out what it's looking like. And so what we need to do is we need to find these little intersections. Right? And how do we find little intersections? We set them equal. So let's do it. So now we're going to say 3 sine theta is equal to 2 minus sine theta. So let's shift some things around. I personally would add sine over and then divide by 4. And so sine theta is equal to how much? 1/2. And so on our unit circle, when is sine theta equal to 1/2? At pi over 6 and at 5 pi over 6. And so when we think about this, it is intersecting at thetas equaling pi over 6 right here and at 5 pi over 6 over there. All right. Is this sketch perfect? No, it doesn't need to be, but this is kind of how to do it. All right. Now, again, when we add up the areas, it's kind of like adding up all of these parts. Remember? And so in rectangular mode, we do top minus bottom or right minus left here. Remember? In polar mode, this is the way I want you to think of it. I want you to think of it as outside minus inside. Where this outer edge is this red one, and the inner edge is this blue one. Are we following? Are we tracking with me? And so what we need to do is we need to find the integral. And what do we have out front? Do you remember? 1/2 out front. And I'm going to go all the way from pi over 6 to 5 pi over 6. And so what is my outside? So when I add these all up, what am I doing on my outside? The 3 sine theta. So my outside would be this 3 sine theta, quantity squared. And then I'm going to subtract my inside portion. So my inside portion would be like these portions right here. And so what would be the inside portion of them? The 2 minus sine theta, quantity squared. And then again, we still have respect with theta. All right, go ahead. All right, what do we get?
5.1962.
All right, fantastic. All right, the year before Kennedy got shot. All right, let's keep. All right, example 6. Example 6. So now we're going to find the area of the common interior. So they're going to share area on this one of 3 cosine theta and 1 plus cosine theta. I'll do this one in red. I'll do this one in blue. So let's make a sketch of what's happening here. So what is this 3 cosine theta? That's a circle. Which way is it going? It's going to the right. All right. So good enough. All right. And technically it goes out how much? 3. All right. And then if I have 1 plus cosine theta, what's that doing? It's a cardioid, all right? And which way is it going? The bulk of it is which way? The right, and then the little cheekies are left, all right? And so now we end up with that, All right. And so we're trying to find the common interior. And so the common interior is this portion right here. Okay. However, what do we need to solve for again? The intersections. So let's do it. And so let's solve for our intersections. And how do we do that? We set them equal. So we'd have 3 cosine theta is equal to 1 plus cosine theta. And again, when we move these things around, we end up getting cosine theta is equal to what? 1/2. So when does that happen? Pi over 3 and? Not 2 pi over 3. Cosine's x, so it's positive, it moves right. So it would be pi over 3 and 5 pi over 3. All right? And this is the way I think of it. So when we split these up, all right, I kind of want you to draw it too. You basically have this portion with the blue, and then you have this portion with the red one. All right, I think of them as little slivers. All right, and so on this one, do I have an outside and an inside very often? No, I don't have that. But I have like this portion with my blue one, my 1 plus cosine, and I have this portion with my red one, which is the 3 cosine theta. Because remember how they add up, kind of like that fan, all right? Or the little slices of pizza, all right? And so this is the way I would break it up, okay? There's lots of ways to tampa. I personally don't like to go negative. So I would do this part first, all right? And how would I do that part? 0 to what? Pi over 3. Of which one? The 1 plus cosine theta. Because that's part of the cardioid, the healthy butt. All right? And so then I'd have 1/2, the integral from 0 to pi over 3 of 1 plus cosine theta squared. However, do I just want one of them? No, how much of them do I want? I want 2.
Mr. Flick?
So how many of them do we have? We have how many? We have 2 of them. So I don't want you to just leave nothing there. I want you to think of it as 2 times 1/2 because that tells you that you're doing it twice. All right? Anyway, so now let's do the other sliver, as what I like to call it. So now we need this sliver right here. Okay? And so what would be that part? Pi over 3 to pi over 2. Now, how did we get to pi over 2? We didn't technically do it. How do I get, what is this thing called again? That little origin is called the what? The pole. So how do you get to the pole? You said it equals 0. So basically, I'm trying to figure out when my circle is equal to 0. So when does cosine equal 0? At pi over 2. And so that's why it goes back. So it goes from pi over 3 and it's going back to the pole at pi over 2. Okay, that's the way I would think about it. All right. And so now I'd have how many of those? Okay, so what's my integrand? 3 cosine theta quantity squared. And how many of them do I have? I have 2 of them. All right, math 9 them, go. We end up with 5 pi over 4. All right, pretty good. All right.
A curve is drawn on the xy plane and is described by the equation and color coordinates are associated plus cosine 3 theta, where pi over 2 to 3 pi over 2, where r is measured in meters and theta is measured in radians. Find the area bounded by the curve and the y-axis.
All right, beautiful. We actually have, do we know what this picture looks like? No. All right. So they will either give you a calculator or more than likely they will have a picture drawn for you. All right. But since we have a calculator and the picture's not drawn, let's go to polar mode for just a sec and we're going to graph this thing. We have our little picture going on. And I only cared about these 2 quadrants. Why did I only care about these 2 quadrants? Because it says from what? Pi over 2 to 3 pi over 2. All right, so now we're going to find the area bounded by that curve and the y-axis. And so what do we got? So now we end up with what? Let's set it up. What's out front?
1/2.
A 1/2. The integral from pi over 2 to 3 pi over 2 of what? Theta plus cosine 3 theta quantity squared d theta. All right, throw it in a calculator. All right, part B.
Find the angle theta that corresponds to the point on the curve with the y-coordinate -1.
All right, so on this one, what do we need? We need a theta with a y-coordinate. Well, what's y? R sine theta. So we need to build y. So my y is theta plus cosine of 3 theta, and then times what? Sine theta. And what am I doing with that? I'm setting it equal to -1. All right, and so in my calculator, I'm going to add 1 to it. All right, so just like we did on what I call day 4, we're going to add 1 to it, and then we're going to grab what?
2.716.
All right, what is it?
3.484 or 3.4850.
50? 50. All right. All right, part C.
For what values for theta, pi to 3 pi over 2 is dr d theta positive? What does it say about r?
All right, so what do we need here? We need values of theta in which dr d theta is positive. So what do we need to get to? Dr d theta. And so what do we need to do here? We actually need to take a derivative of it. So what's my derivative of r with respect to theta? What's the derivative of theta? 1 plus, or not really going to be plus. All right, what's the derivative of cosine of 3 theta? Negative 3 sine of 3 theta. All right, and so now what am I going to do with my calculator? It says when is that what? Positive. So I'm going to graph that and figure out when it is above the what? The x-axis. All right. If on the interval pi to
4.3021.
1. All right. Now, what does this say about r?
R is getting further from the pole.
R is getting further from the pole. R is
Changing.
changing in a positive way. R is getting further from the pole. I like that. All right. R is increasing. It is getting further away. All right, part D now.
Find the value of theta on the interval pi to 3 pi over 2 that corresponds to the point on the curve with the greatest distance from the origins. What is the greatest distance? Justify your answer.
All right, fantastic. So on this one, this is basically asking for a greatest distance, which is another name for a maximum. And so what do you need to do for a maximum? Take a derivative and set it equals 0. Okay, we kind of just did that, but you need to show that you tested what?
Goes from positive to negative.
Your endpoints. I need you to show that you tested your endpoints. So the way that I want you to do it is I want you to set up a little chart. Okay? And so what 2 are we going to test for sure? Pi and what? 3 pi over 2. And then the other one, we kind of just did it. We're going to test what? 4.3021. And so now I'm going to take those and I'm going to substitute those back in for r. All right? And so we're going to substitute those back in for r now. All right, so at pi, what's my r? Anybody? 2 point what? 1416. All right, and then at 4.3, 49. All right, and then at 3 pi over 2. All right. All right. And so now, which is like 4.7 something. All right. So now, what's the answer to my question? What is the greatest distance away? No, that's the when. So what is the greatest distance? 5.2449. All right. If it said when is it at the greatest distance, then we would give the what? the theta value, but it said what, and so we need the value. All right, and so justifying the answer is what? The little chart. That would be my method of doing it. Okay, it's much less wordy than what you need. All right, and if you look at the little picture, if our theta value is 4 point something, it's going down here, and so that's the furthest away. All right, pretty good? All right, so numbers 7 through 15. All right.